Australia feels like the safest place on Earth, geologically speaking. No megavolcanoes, no massive fault lines slicing cities in half, no constant earthquake alerts. It looks solid and unbreakable, but according to a brand new global stress map of Earth's crust, Australia is one of the most internally stressed pieces of land on the entire planet. It's not shaking or cracking yet, but it's quietly storing energy like a bent ruler about to snap. To understand why this is such a big deal, imagine Earth's crust like a giant jigsaw puzzle made of moving slabs called tectonic plates. These plates float on softer rock below and push, pull, or grind against each other. Where plates meet, earthquakes and volcanoes make sense. But stress doesn't just stay at the edges, it travels. It builds up inside plates too, like pressure spreading through frozen ice when you squeeze it. Scientists mapped over 100,000 real stress measurements from oil wells, rock tests, and earthquakes to see where Earth is being squeezed the hardest right now. When they laid all the data together, the map lit up like a warning sign, and Australia stood out. This shocked scientists because Australia sits far away from plate boundaries, which usually means stability. But instead of relaxing, the Australian continent gets squeezed from multiple directions by nearby plates, especially the Pacific and Eurasian ones. The stress doesn't release easily, so it piles up inside the crust, and then nothing moves. Until suddenly everything does. One of the strangest discoveries showed up in places like the Bowen Basin, where stress directions twist and rotate underground. That's bad news because unpredictable stress behaves like glass about to shatter. These rotating stress fields make it nearly impossible to say when or where cracks could form. It could be years away or tomorrow. And human activity makes it even riskier. Drilling deep into the crust for geothermal energy or injecting fluids underground can nudge these stressed zones just enough to trigger fault movement. This doesn't mean Australia is about to split in half next week. But it does mean the idea of geologically safe might be outdated. Scientists now think Australia could eventually fracture internally and form new fault systems where none existed before. What makes the new stress map different from older models is that it doesn't just explain past earthquakes, it helps identify future risk zones before anything breaks. Countries can use this data to decide where drilling is safer, where tunnels shouldn't go, and where infrastructure needs reinforcement. But even with all this data, we still can't predict the exact moment Earth will snap. Stress maps tell us where the tension is. They don't tell us when it gives up. But this idea of continents quietly tearing themselves apart isn't just theory. Africa gives us the clearest real-world example. It's slowly unzipping itself. So slowly that no human will ever wake up and see a new ocean where land used to be, but fast enough that scientists can actually measure it happening right now. Deep beneath East Africa, the ground stretches, thins, and pulls apart as if the continent is taking a deep breath and never fully exhaling. And over millions of years, that stretch could turn into an ocean. This whole process centers on something called the East African Rift System, or EARS for short. Think of it like a giant tear running through the continent, thousands of miles long, cutting through countries like Ethiopia, Kenya, Tanzania, and Mozambique. It's one of the biggest rift zones on Earth. A rift zone is exactly what it sounds like, a place where the planet's crust is being pulled apart instead of squeezed together. And Africa just happens to have one of the most dramatic examples anywhere on the planet. What's really happening is that Africa isn't one solid plate anymore. It's splitting into two massive chunks, the Nubian plate to the west and the Somalian plate to the east. These two plates are drifting away from each other at a speed that sounds laughable, just less than an inch per year. That's about the speed your fingernails grow. But give that process millions of years and suddenly continents don't look so permanent anymore. In 2018, photos of a giant split in Kenya went viral across the internet. Headlines screamed that Africa was splitting in half right now. It looked dramatic, but that moment didn't mean Africa suddenly broke overnight. That rupture was more like a surface ripple. a small local sign of a much bigger process that's been going on for around 25 million years. And if we could travel in time to 5 or 10 million years from now, we would probably see the crust thin enough for seawater to rush in. When or if that happens, East Africa would slowly peel away from the rest of the continent, and a brand new ocean basin would form between the two plates. Africa would lose its eastern shoulder, and maps of the world would need a serious update. As strange as that sounds, it's actually totally normal for Earth. The planet never stops reshaping itself. It just works on a timeline so slow that our brains struggle to process it. The continents we know today feel ancient and permanent, but they're basically temporary arrangements. About 138 million years ago, South America and Africa were locked together like puzzle pieces. You can still see it if you look at their coastlines. They match almost perfectly. East Africa drifting away will just be the next chapter in that story. Australia's story could follow a different path, but the physics are similar. Stress builds, rock resists, then the rock fails. And stress doesn't care about borders, cities, or how calm the surface looks. That's why scientists are so concerned about something called SH max, the direction of maximum horizontal stress. In simple terms, it tells us which way the Earth is squeezing the hardest underground. If that squeezing lines up with existing fractures, earthquakes become more likely. If it cuts across old faults, new ones can form. Turkey is another place where the stress map practically screams danger. The country sits where Arabian, Eurasian, and African tectonic plates collide. There's also a smaller Anatolian plate on which Turkey is located, and which gets squeezed westward like toothpaste, grinding against massive faults. The stress map shows SH max pointing in directions that load these faults perfectly. Now, researchers looked at ancient lava flows near one of Turkey's faults and realized they weren't random. Lava sheets once flowed smoothly across the land, cooled into solid rock, and then got pulled apart over time, like a snapped chocolate bar. That gave scientists a rare, clear snapshot of how continents deform from the inside out. To date the lava, the team used microscopic zircon crystals trapped inside it. These crystals work like natural stopwatches. They trap helium created by radioactive decay, and by measuring that helium, scientists can tell when the lava erupted and cooled. When they combine that with satellite images and remote sensing, the scientists managed to see Earth's slow-motion movements. The Tuzgolu Fault stretches more than 120 miles and is so massive that you can spot it from space. For years, scientists assumed it behaved like many of Turkey's dangerous faults, where land slides sideways past itself. But this new research flipped that idea on its head. The fault isn't sliding, it's slowly ripping open. The land on either side moves away from each other at less than an inch per year. That sounds tiny, but then again, over thousands or millions of years, that motion adds up to continents literally thinning and breaking. And since the fault sits where three massive tectonic plates meet, this matters way beyond Turkey. All this once again reminds us that continents don't just collide or slide. Sometimes they stretch until they snap. And places that look calm on the surface might already be under invisible strain, inch by inch, year after year, rewriting the map long before anyone feels the shake. Boom! A fiery rock the size of a skyscraper tore through Earth's atmosphere. It slammed into the ground with unimaginable force and sent shockwaves rippling through the continents. When the chaos finally settled, something strange glimmered on the ground. Shards of glass scattered across southern Australia. But these weren't ordinary shards from your chandelier. They were tektites. That's a fancy name for strange, glassy, pebble-like objects, which are like leftovers from a meteorite impact. Scientists had seen these before. The last batch they found came from a meteor strike that happened about 780,000 years ago, which is already mind-blowing. But this new discovery? Even crazier. These tiny glass pieces seem to be around 11 million years old. And here's the twist. Their chemical makeup didn't match any known impact site. They were totally different, like fingerprints from a stranger. That means they must have come from a completely separate asteroid strike. One so huge, it blasted debris all across the continent. Of course, scientists wanted to find the massive crater that caused all this, but it wasn't as easy as they soon realized the asteroid might not have hit Australia itself. It could have crashed somewhere hidden, maybe deep under the thick rainforests of Southeast Asia, or beneath the rugged mountains of Papua New Guinea. Over millions of years, the Earth's surface shifted, eroded, and transformed, so it could have covered up the crater completely. Yep, it's like finding a needle in a haystack. All that remains today are these mysterious glassy clues, and wow, those tektites are mesmerizing. Some look like tiny drops frozen in midair. Others are stretched and sleek. Their black, shiny surfaces catch sunlight in a way that almost makes them look alive. But these little gems aren't just pretty. Inside them are traces of silicon, aluminum, and iron. It's all evidence of unimaginable heat, the kind that melts solid rock. I mean molten debris shooting through the air, cooling down into glass before it even hits the ground. That kind of heat. That's how powerful the impact was. The bang must have been enormous, and it spread glittering fragments across hundreds of miles like a cosmic version of confetti. Discoveries like this remind us that Earth has faced more massive asteroid strikes than we once believed. By studying what these tektites are made of, scientists can tell how big the asteroid was, how it hit, and what kind of chaos it caused back then. It's wild to think that the peaceful, sun-baked lands of southern Australia, now home to kangaroos and red dust, were once ground zero for a fiery cosmic impact. If you're waiting for a plot twist where the mystery was solved, I'm sorry. But even with all our fancy satellites and tech, scientists still haven't found the crater. It's like the asteroid hit, left these shiny breadcrumbs behind, and then disappeared without leaving a footprint. Southern Australia now holds these glass shards like a secret diary from millions of years ago, just waiting for humans to piece the story together. Until then, let's visit a couple of impact craters scientists have already pinned down. In the middle of Western Australia, in the ancient Pilbara region, geologists found what might be the oldest impact crater on Earth. It's probably about 2.7 billion years old. Yep, that's billion, with a B. At the time it formed, this gigantic crater would have stretched nearly 60 miles across. Of course, after sitting around for a few billion years, time and weather did their thing. The once sharp crater got worn down and reshaped until it became more like a dome than a bowl. What's left today is called the North Pole Dome, and we can still see about 20 miles of its raised center. To put things in perspective, our planet is around 4.5 billion years old, but most of what we know about meteor strikes comes from much younger rocks. You see, over billions of years, erosion, volcanoes, and plate tectonics have recycled and reshaped most of Earth's original surface. So, finding any piece of crust that old and still showing impact scars is like uncovering a fossil from the dawn of time. Between 4 and 2.5 billion years ago, Earth was totally different. It was completely covered in water, and maybe a few lonely bits of land sticking out. Volcanoes were erupting like crazy. Chemicals were swirling in the oceans, and continents were just starting to form. Most of that early crust got destroyed or buried long ago, so surviving pieces like this crater are unbelievably rare. Then, about 2 billion years ago, Earth went through a wild snowball Earth phase. Ice stretched from the North Pole all the way to the South Pole. But before that icy chapter, something dramatic had already happened in what's now Western Australia. A meteorite came crashing down. This idea fits perfectly with another theory scientists have, that billions of years ago, space rocks were going after the moon, and since the Earth is right next door, it probably took just as many hits. We just lost most of the evidence because our planet constantly reshapes itself. So, a research team went out to North Pole Dome to see what they could find, and after just 1 hour, they struck gold. They discovered something called shatter cones. delicate cone-shaped patterns that form only under the unimaginable pressure of a meteorite impact. You literally can't fake those. Using those shatter cones, the scientists dated the impact to around 3.47 billion years ago. And they think this crater might have been about the same size as the Chicxulub crater in Mexico, the one famous for wiping out the dinosaurs 66 million years ago. That's how massive this ancient strike was. But that's not all. The team also found tiny droplets of molten rock that got blasted into the sky when the meteor hit, cooled down midair, and then rained back to Earth. Some of them even landed as far away as South Africa. Scientists are still studying this crater, so let's leave them to it and hop to our next destination, the North Sea, or more precisely, under it. There's been this mysterious dent in the Earth hiding under layers of rock for millions of years, about 80 miles off the coast of Yorkshire. The crater is almost 2 miles wide. Scientists first found it back in 2002, called it the Silver Pit Crater, and ever since, it's been the geological equivalent of a true crime mystery. Was it caused by an asteroid slamming into Earth, or was it something more boring, like shifting salt beds or an ancient volcano that just sneezed? For 20 years, experts argued about it, but now, after 2 decades of back and forth, researchers finally cracked the case, and the asteroid team wins. Turns out, something from outer space carved out Silver Pit more than 40 million years ago. A research team used super detailed 3D seismic imaging, which is basically Earth's version of an MRI, and they also took old drill cuttings from an oil well from the 1980s. When they put all the data together, they saw the signature shape of an impact crater. It has a raised middle, a ring of broken rock, and even little mini craters left by debris that flew back down after the hit. The cracks in the rocks were stretched apart on one side and squished on the other. It was proof that the asteroid came in at an angle, not a straight shot. Microscopic quartz grains from the drill samples sealed the deal. Under the microscope, they had these weird crisscrossed scars that only form under insane pressure. I don't envy anyone who gets hit by something moving at 9 miles per second, and that's exactly what happened to our planet. Scientists think the impact happened sometime between 43 and 46 million years ago. Back then, the world was warmer and the oceans teemed with life. So you can imagine the chaos it must have caused, though thankfully, no dinosaurs were around to worry about it. They'd been gone for 20 million years by then. This is Australia, and here, a little to the south, is its island part called Tasmania. It's a giant island with beautiful and rich nature, great weather, and delicious food. But for some reason, very few people live here. Something makes people leave this place. Something prevents people from moving here. And this something is… let's find out. So, the population of Tasmania is over 500,000 people. That's not a lot. In fact, Tasmania is Australia's smallest state by population, but it's the 26th largest island in the world. Its area is about the size of Ireland or Switzerland. In other states, the area is much smaller, and there are quite a lot of people. For example, over 8 million residents live in New South Wales, more than 7 million in Victoria, and over 5 million in Queensland. Also, mainland Australia is much more likely to endure fires and scorching sun. Tasmania has a fairly cool climate and amazing nature. So, what's the reason? Why do so few people live here? Let's visit the southeastern part of Tasmania, where the Tasman Peninsula is located. If you look at the map, you'll see that there's the Tasman Sea connected to the boundless Pacific Ocean. So it looks like the Port Arthur we're going to visit is on the edge of the world. In the past, there was Tasmania's official prison here that opened in 1830. Prisoners served their sentences and worked at a logging station. It was hard work, and many could not survive it. It's scary to imagine what happened inside the walls of this prison and how many people stayed there forever. But think for yourself. The Tasman Peninsula is on the edge of the world. There's almost nothing here except wild nature. Prisoners arrived there on ships and spent long hours doing hard work. There was no air conditioning or a soft bed. There was no hope of getting out of there. Some guards treated them cruelly. They were starving. Some got bitten by venomous snakes. There was nowhere to escape. The prison closed in 1877, but even today, it still inspires horror among tourists. Not only because of its appearance and history, but also because of the strange phenomena that occur there. According to rumors and legends, the spirits of prisoners roam the territory of Port Arthur. And on Monday morning, you can hear bells ring in an old ruined church building. But the thing is, the bells haven't been there for a long time. Of course, those are all rumors, and there are no confirmed facts. But you might feel uncomfortable in this place because of its sinister past and creepy atmosphere. Port Arthur is one of the most mysterious places in Tasmania. But there's something worse. Welcome to Franklin House. It's a large estate with gardens and a huge building. There's a chance that as soon as you cross the threshold of this house, you will want to leave immediately. There are a lot of antiques here, but there's also something elusive and sinister in the air. This house was built by a former convict. 4 years after the construction, he leased the mansion to a schoolteacher who turned it into an academy for boys. It's not known what happened in the walls of this building in the past, but today, according to rumors, mysterious phenomena take place here. Objects move by themselves. Eerie noises come from empty rooms, and shadows of human figures are spotted in halls. Plus, according to a non-profit company that researches mysterious phenomena, there's an increased level of electromagnetic activity in this house. What does it mean? Nature? Weather? Or phantoms? Choose for yourself what to believe in. Okay, there are 2 creepy places in Tasmania, but the reason why people leave this place is different. We're getting closer and closer to it. Hobart is the capital of Tasmania, and there's an old prison here, where people still run tours. Tourists come here to tickle their nerves, because the most terrible sentences were carried out here. There are rumors about strange smells, flickering shadows, and a creepy atmosphere that make this place scary. Yes, if you're a tourist and come here for fun, you will get an interesting experience. But if you're a local and live nearby, then maybe it might bother you. But of course, an abandoned old prison wouldn't discourage people from living on a giant, picturesque island. There's a bigger reason. There's a city in Tasmania called Richmond. According to local legends, once upon a time, George Grover lived here. He was a security guard who kept order during the construction of the Richmond Bridge, which was built by convicts. George Grover was an evil man who treated prisoners cruelly. One day, the prisoners decided to take revenge on him and pushed him off the bridge. Since then, rumors have been circulating that the spirit of George Grover is walking under the bridge with his big black and white dog, which is called Grover's dog. Tourists and locals reported they had seen this evil security guard at night. He didn't harm them, but gave a severe fright. Many terrible events related to escaped prisoners also took place on the island, so judging by the history of Tasmania, there's been a lot of pain and misery here. Perhaps this affects the overall energy of the island. But is this the reason why so few people come to live here? Now we'll finally learn the most terrifying explanation. Are you ready? Please get away from the screens if you're faint of heart. There's almost no internet connection in some parts of the island. Boo! The signal is very weak and unreliable, which makes it impossible for people to work remotely and watch our videos. Besides, Tasmania is separated from Australia by the Bass Strait, which creates logistical difficulties for trade and traveling. Today in 2025, would you agree to live on a huge island with bad internet? You will also have to pay more and wait longer for the delivery of any goods. One of the main sources of income is tourism. In addition, rental prices are rising here, especially in central cities. Because of logistical difficulties, prices for food and necessities are rising here. One of the biggest problems is waiting lists in public hospitals in Tasmania. People who need modern medical care have to wait a long time for their turn, or they gotta spend tons of money to get to the mainland. Tasmania is getting old. More and more young people are leaving this place. There are no major corporate headquarters on the island. There are no large enterprises here like in Sydney and Melbourne, which means there are few career opportunities. Low salaries and unemployment are forcing young people to move to the mainland. The falling standard of living creates serious demographic problems. On the one hand, this is bad. The fewer people there are, the more difficult it is to raise the economy, to run agriculture, and somehow improve this region. But on the other hand, it's good for nature. About 24% of Tasmania's land area is a World Heritage Site. This territory is one of the last in the world to have cool rainforests. It's also home to one of the richest archaeological sites in Australia. Scientists found evidence that people lived here at least 20,000 years ago. Of course, these factors are not as creepy as the stories about haunted houses, but they can scare you away from moving to Tasmania. The idea that you live almost on the edge of the world, surrounded by the endless waters of the ocean, can be scary. You can meet unique animals that don't live anywhere else in the world and see incredible trees. For example, the centurion tree, which is eucalyptus, is one of the tallest and oldest trees in the world. Its height is about 330 feet, and its age is about 400 years. The nature of Tasmania is incredibly beautiful. There's so much peace and calm here. In a sense, it's a paradise. But let's be honest. Would you agree to live here considering all the nuances? Let's hope that people will find ways to improve the economy and raise the standard of living so young people won't leave this region. Take a look at Australia from space. Nothing unusual, right? But now focus on the northern territory of the continent. If we imagine it through magnetic sensors, we notice, whoa, see that? An unknown strange thing that mirrors the outline of Australia itself. It looks almost the same, but smaller. It's like a twin of the continent hidden deep within it. But what is it? Volcanic lakes? Gold deposits? No, it's something far stranger. This is a magnetic anomaly. Yeah, you're probably confused, but let's find out what's going on with Australia. So, there are devices called magnetometers. They measure magnetic fields, and geologists use them for many things, including exploring the interior of our planet. The magnetic field comes from various metals and minerals buried deep underground. It travels upwards, and scientists' sensors detect it. One day, they equipped aircraft with these magnetometers and flew over the northern part of Australia. When they processed the data and identified a magnetic anomaly with clear geological boundaries, whatever lay in Australia's interior was emitting magnetic signals and followed the outline of the entire continent. And because these signals come from deep rocks, scientists think that valuable resources, including minerals and metals, might be hidden there. But beyond potential resources, what else does this tell us? Inside these rocks, there could be volcanic materials formed over 1.5 billion years ago, minerals that formed long before the dinosaurs appeared. This entire mass of material could tell scientists about our planet's history and how the Australian continent was formed. Okay, that sounds cool, but why are those changes in the magnetic field they detected called an anomaly? Why is it magnetic in the first place? And how does this magnetism work? To understand, we first need to grasp what Earth's magnetic field is. And this is one of the most amazing and mysterious things in the world. The magnetic field is invisible, yet without it, we couldn't exist. So, in simple terms, Earth's magnetic field is our protective blanket, shielding us from cosmic radiation, charged solar particles, and the solar wind. Without the magnetic field, our Earth would be like Mars, a barren desert where life most likely couldn't have emerged. But where does it come from? The magnetic field is generated deep within our planet, where molten nickel and iron create electrical currents. Combined with our planet's rotation, these electrical flows generate the magnetic field that protects us. In addition, minerals and metals inside rocks can produce magnetic fields too. But what exactly is this force? Take two magnets from your fridge and try to push them together. Feel that resistance? That repulsion happens because their magnetic fields are interacting. In some places, this magnetic field can be weaker, and in others, stronger. This means that deep within the planet, in those locations, there are geological processes happening that change the stable behavior of the magnetic field. These places are what we call magnetic anomalies. One of them lies beneath the northern part of Australia. However, the magnetic field is more than just a blanket. Thanks to it, many awesome things happen. For example, a compass needle always points north because the Earth's south magnetic pole is located there, attracting the magnet. Don't confuse the geographic and magnetic poles. The geographic North Pole is in the north, near the magnetic South Pole. It's not just humans who use the magnetic field for navigation. Animals can do it too, without any instruments or technology. Some animals sense the magnetic field, and this superpower is called magnetoreception. This ability helps animals during migration. That is, they know where north and south are. So when it gets cold, they can fly to where it's warm. For some turtles, magnetoreception helps them remember the location of feeding areas. Pigeons have a unique perception of the magnetic field too. In simple words, the magnetic field is also a giant navigation system for many creatures on Earth. Few people know, but we actually have a second magnetic field. In 2018, scientists published research describing how ocean tides create another magnetic layer. But why hadn't we noticed it before? Our main magnetic field, generated by the planet's core, is very strong. Its radiation extends into space and is easy to detect. The magnetic field from tides is almost 20,000 times weaker. How does this field affect the main one? What are its properties? Scientists continue to study these questions. Also, the magnetic field can control the brain. In 2017, scientists used magnetic fields to remotely activate brain cells in mice. Magnetic forces were directed at the parts of the mouse brain responsible for body movement. In this way, the scientists could make the rodent run, freeze, and turn around. But don't think this was done just for fun. Experiments like this can be very helpful for humanity. If you can make a small animal move, imagine what other changes might be possible in the brain. Improving psychological state, for example. Potentially, you could instantly switch from a bad, depressive mood to a happy one. This technology could help treat many diseases related to the brain and nervous system. You might think that such a technology could control you, but don't worry. Magnetic fields pass through your tissues with almost no effect. But then, how did they manage to control those mice? Scientists simply implanted tiny magnetic particles into the animals' brains. Under the influence of a magnetic field, these particles heated up and triggered the activation of neurons. But the coolest thing happens when the magnetic field collides with the solar wind, generating electrical currents and magnetic forces. At the moment, a true cosmic storm happens in the sky, and we see it in the form of beautiful auroras. Such storms are not only beautiful, but also destructive, as they can disrupt the operation of satellites and electronic devices. Sometimes this can lead to minor glitches in your GPS or internet connection on your phone. But there have been cases where magnetic storms were so massive, they led to catastrophic consequences. One of them occurred in 1859 and is known as the Carrington event. On September 1, 1859, an amateur sky watcher, Richard Carrington, noticed a sudden bright white flash on the sun. It turned out this flash was a massive ejection of plasma from the sun's upper atmosphere. About 17 hours later, part of this energy reached our planet and struck as a powerful storm. All telegraph systems at the time went down. The northern lights were visible not only to residents of northern regions, but also in the tropics. For many people who had never heard of or seen the northern lights, this was a real surprise. What must they have thought? The end of the world? Unknown forces from space? Many were undoubtedly shocked by the spectacle, but the real shock was inside major cities. Communication between telegraph systems was stopped. The world was plunged into an eerie silence. Sparks flew from telegraph machines, causing fires in some places. People couldn't send or receive important information. Fortunately, the consequences weren't too catastrophic. Communication technologies were just beginning to develop at that time. But what would happen if such an event occurred today? Many experts have estimated that the damage from a similar storm in the United States could reach up to $2.6 trillion. the entire internet would shut down. For a while, we would lose access to our messaging apps, our banks, our navigation systems. Contactless payments, airports, train stations, and much more would stop working. We would be cut off not only from the internet but also from electricity for a long time. The entire planet would be plunged into darkness and silence. A global economic and humanitarian crisis would begin. It's hard to imagine the damage that AI would suffer. But don't worry, the good news is that storms like this happen roughly once every 500 years, and smaller ones about every 50 years. But these aren't precise forecasts, since it's quite difficult for scientists to predict the sun's behavior. Besides, we wouldn't just sit in shock after such an event, we would immediately begin dealing with the consequences. The impact on modern civilization from such a storm would be significant, but we would surely recover quickly.
So a few years ago, in 2019, folks in Australia said they liked an old idea with a new twist, using extra floodwater from the north to help dry areas in the west and south. This plan got the name of the New Brainfield Scheme. It was based on an old idea from the 1930s. The idea was to catch floodwater from the north and move it to the south and west. But the original plan never actually happened. Over the years, lots of experts said it wouldn't work. They thought it was too expensive and too tricky to build, even though it could potentially help fix drought problems in dry parts of Queensland. The original idea appeared a long time ago, when an engineer named John Brainfield got a big idea. He wanted to take floodwater from rivers in northern Queensland and send it inland to Lake Erie, one of the driest spots in Australia. He planned to use dams, pumps, really big pipes, and even tunnels to transport all that water over the Great Dividing Range, a big mountain range in Australia. The biggest dam would have been called Hell's Gate, and Brainfield wanted it twice as tall as what it was originally planned. This way, pumps and gravity could help move the water over the Great Dividing Range. The water would then flow south and help irrigate farmland near places like Hughenden. It would change the weather, make it rain more, and turn the dry land into green farms. Eventually, it would reach Lake Erie, turning the desert into a green growing area. That way, Australia could grow more food, sell it to other countries, and make more jobs. He hoped that the area could turn into a food bowl for the country. For some time, people talked about the plan a lot. They loved the idea. They thought it could change how farming worked. And some even believed that nature had already planned for the land to be filled with water. Dry rivers and lake beds were just waiting to be used. They even said that rains fell on the wrong side of the mountains, and Brainfield's plan could fix that. But when the authorities looked into this idea, they found big problems. And the main one was that the plan would cost too much. Plus, there weren't enough scientists or engineers to do a full investigation. The land was too dry and harsh. No one was sure it would even work, like how much water would really get there. Plus, some of Brainfield's measurements were wrong, especially the dam heights. So, in 1947, they officially shut the project down, claiming that even if they built the project, it wouldn't be worth it. After all, even places next to oceans, like parts of Chile, still stay bone dry, so a big lake might not result in more rain. And still, in 2019, one political party brought the idea back with an updated version called the New Brainfield Scheme. They wanted to try it again, but with some changes to make it work better. Their plan included the following steps. Take water from the South Johnstone, Tully, Herbert, and Burdekin rivers. Store that water using a big dam called Hell's Gate Dam, but this time they wanted to make the dam twice as tall as in the original plan. Let the water flow through tunnels using gravity, instead of using lots of pumps. Move the water under the mountains and into the Warrego River in southern Queensland. Use the water to grow crops in dry places south and west of Hughenden, a huge area even bigger than Tasmania, eventually turning it into a food bowl. At the same time, they didn't say how much the whole project would cost, but they promised to spend $20 million to let Australia's National Science Agency check if the plan could work. Those innovative ideas sounded good, but for over 80 years, loads of experts kept saying, "Nope, it won't work." Why? Branfield said his idea would cost £40 million back in 1941. That's about $3.2 billion today. But the new version of the plan might cost more than $15 billion and take over 10 years to build. Also, people who care about nature are worried. They explain that taking water away from where it usually goes could hurt animals and plants. It might let invasive plants and animals spread to new places. It might mess up rivers and oceans, where fish and other animals live. It could even hurt towns and businesses near the coast that depend on those natural water flows. Still, some people really believed in the idea and thought it was worth doing, especially to help farmers and fix drought problems. However, in 2022, the government decided to stop trying to fix the drought in western Queensland with the Branfield scheme. Experts looked closely at the plan and said it just wouldn't work. The problem? There's not enough water all the time to make it happen. Apparently, the new cost of the plan would have been over $30 billion. That's a huge amount of money. You could buy yourself a fleet of private jets and luxurious yachts, and more. So experts said you'd need lots and lots of water to spend that kind of money, but the water just isn't there. Now, instead of one huge project, they suggested doing smaller water projects closer to where the rain and waterfalls are. These smaller projects, called mini Branfield grids, would be in 4 places along the Queensland coast. Those little grids could share water when some places had more or less rain. Other scientists looked at the plan too, and they agreed. Even if things went super well, the Branfield scheme would still cause problems and cost way too much, while the mini water grids project looks more plausible. They think the dry parts west of the mountains will do better without the full-scale Branfield scheme. There are easier and cheaper ways to help those places grow and get water. So the big plan was dropped, and now they're looking at smarter, smaller ideas to help with water and farming. And the matter is quite urgent. Australia is a super dry place, one of the driest places people actually live in. When there's a drought, there's not much water around. That means farms don't grow as much food, and that can cause a lot of problems. In the future, droughts are likely to happen more often and be worse. That's why it's necessary to start getting ready now. Experts are working on something called the Drought Resilience Mission, trying to figure out how to deal with droughts better in the future. One of them looked at how much droughts actually cost Australia. His research shows that droughts can hurt a lot of things – farms, jobs, towns, and even the whole country. When there's no rain for a really long time, some towns can actually run out of water. That's called day zero. It's when the taps in people's houses get turned off because there's just no water left. In 2020, a town in Queensland called Stanthorpe hit day zero. About 50 other towns were really close too. When such a situation happens, the only way to get water is by bringing it in with trucks, and that's super expensive. Stanthorpe had to get around 20 trucks of water every day for a year and a half. It cost them about $800,000 every month. In the end, they spent over $14 million just to have water. Luckily, it started raining again and filled the dams back up. But the authorities are working on ways to stop this kind of thing from happening again. They want to help towns be ready so they never run out of water like that. Because drought just doesn't mess with water, it can also mess with people's health. When everything dries up, plants vanish and the soil gets loose. Then the wind picks it up and makes huge dust storms. Those dust clouds can blow really far, even into such big cities as Sydney. That's what happened in 2018. The air got so bad that kids, older people, and anyone with breathing problems had to be extremely careful. The dust ruined some crops and made different foods, even fruit, unsafe to eat. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay